Okay, today we're going to solve equations in section 1.4. Generally, we work in reverse order of operations. We're not quite doing reverse order operations though in this first one. I would guess if I set you loose, most of you do a pretty good job of getting this solved. Anyways, here's how we do it. I would say distribute the -4. If you distribute the -4, it turns into -4x. And then you have to treat this as negative. So take negative times -2 and you get a positive 8. That equals -22. So we got rid of parentheses. Now you don't actually have to get rid of parentheses, and I'll show you that in the next problem, but that's what I would think most of you would do at this point. Now I would say you'd probably add like terms. And the 10 and the 8, they're like terms, they're just regular numbers, and they're on the same side. So you just put them together as they are. 10 plus 8 is 18. Minus 4x equals -22. Now you have 2 steps left. You got to get rid of the 18 and the -4. The 4 is using multiplication. We do reverse order of operations, so you actually get rid of the adding and subtracting first. So we're going to subtract 18 because 18 minus 18 is 0. That'll leave us with -4x equals -40. And then to get rid of the -4, we divide because that's multiplied. So we get x is 10. I circled it a little prematurely. I probably should check my answer. Let's do that over here. We're going to plug in a 10 and make sure that it does, in fact, equal -22. If it doesn't equal -22, we made a mistake. Order of operations, do the parentheses first. 10 minus 2 is 8. Multiply before subtract, so 4 times 8 is 32. 10 minus 32 is, in fact, -22. Feeling good about my answer of 10. Second problem. This one, I mentioned up above that you don't have to do the distributive property. You can actually do reverse order of operations. So reverse order of operations means you would do parentheses last. Because in order of operations, you do parentheses first. So rather than even mess with the parentheses, I'm going to deal with them last. Because
Natalie,
I don't want
to the art room, please. Natalie Hampton
pardon the
to the art room.
interruption. I don't want to distribute because then I got 2/3 times 5 and then 2/3 times 7. I got fractions. So what I would rather do is get rid of the 2/3 first. I'm going to get rid of the 2/3 first. Then I get rid of fractions with multiplying by their reciprocal. So I'm going to multiply both sides by 3/2. That'll cancel out the 3 and the 2 and leave me with 5x plus 7 equals whatever 18 times 3 over 2 is. Now when I do 18 times 3 over 2, I actually divide the 18 by the 2 first in my head, make that a 9, and then I do 9 times 3 in my head and get 27. So that's how I multiply by those fractions. It's perfectly legal to do. Do the division first to make the number smaller, and then multiply. And now we just have the 2 steps. Subtract 7, divide 5, get your answer 4, plug it up above and check it to make sure you do get 18. I'm going to take a quick mental check, see that I do get 18, and I do, and move on from there. Third example, we've got x's on both sides, plus over to the right I've got special situations. So let's be aware of that. Let's see what happens here. This one, because I have x's on both sides, I'm going to distribute on this one so I can put things together. So I'm going to get -4x and -6. -2 times 2 is -4, -2 times 3 is -6. 5 plus 2x equals. Okay, so now I can put stuff together on the right, and I'll get 2x minus 6, because when I subtract the 6x minus 4x, I get 2x. And on this side, I have 5 plus 2x. What do we do when we have x's on both sides? Well, we got to move to the other side. Normally what I'd have you do is subtract over the smaller one. Well, in this case, they're the same, and if you go to subtract them over, what weird thing happens, they cancel and you end up with 5 equals -6, which if I told you 5 equals -6, you'd be thinking, not true. So I might want to double check to make sure that the x's canceling out is actually what did happen. So I would check my steps over, and I'm checking them here quick, and it looks like, yeah, the x's did cancel. So that gives us a special situation over here. And here's what you do. When x's cancel, and you get a false, false statement, like we got over here, like 5 equals -6. That's false. So when you get a false statement, put no solution. Okay, that one can't be done. These are two linear expressions. 5 plus 2x is a linear expression, as is 2x minus 6. It'd be like this. I've got $5 and I get $2 an hour, and you owe somebody $6 and you get $2 an hour. When are we going to have the same amount of money? Well, never. We're getting the same amount per hour, and you start farther down than I do, so we're never going to be the same. There's one other thing that can happen here. X's could cancel, and you could get a true statement. And you get a true statement. When that happens, you need to write infinitely many solutions. I don't know what they are, but there's infinitely many of them. Wow. I guess I do it there. There's infinitely many numbers. Any number will work, so you just put infinitely many solutions. And that's if you end up with something like 5 equals 5 or 0 equals 0. That's when you do that. Okay? All right, last one, word problem. Love it. This is one that we're going to work on. This is going to be one of these on the test, so make sure you get it figured out. I got an opening statement of the length of a rectangle is 2 more than 3 times the width. Key word here is. Is in math means equals. And there's 2 things I'm talking about, length and width. So I'm going to use 2 letters for those things I'm talking about. I'm going to use L for length, and I'm going to use W for width. And I'm going to try to set up a problem here. All right, the first sentence says length is. So I'm going to say L is, length is. L is my length. 2 more than. More than means if I said you had 2 more than me, if I had $10, that means you have $12. And how do you get that? You add. So 2 plus. 2 more than is 2 plus. And then 3 times the width. So we'll do 3 times the width. That's an expression for length. Length equals 2 plus 3 times the width. The perimeter is 60. Okay, so we have the perimeter is 60. So what does that tell me? How do I find the perimeter of a rectangle? Well, perimeter is distance around a rectangle. A rectangle has a width, a length, a width, and a length. So perimeter is 2 lengths plus 2 widths. I mean, you could put L plus W plus L plus W, but when you add like terms, you get 2L and 2W. So I want 2L plus 2W not to be P. I said the perimeter is 60, so I actually want that to be 60. And now I want to actually come up with the dimensions. Well, what we're going to do here is just substitute for the L. L right here is L right here. So rather than thinking of this as L, I'm going to think of it as its equivalent, which is 2 plus 3W. And 60 equals that. So all I did was take this L, replace it with 2 plus 3W, because that's what we were told up here. And now I have an equation we can solve just like we solved up above on the previous page. I can distribute 2 and get 4 plus 6W plus 2W equals 60. Add like terms and get 8W plus 4 equals 60. Subtract the 4 and get 56 equals 8W And then finally, let's get that W on, and we got that W is 7. So the width is 7 units. I didn't tell you what unit to use, so the width is 7. And then I said I want to know both dimensions, I believe, so we need to find the length. And let's recall that the length is 2 plus 3 W's. That's what we're told. Well, I could have revised this out right here and turned it into 2 plus 3 W's. So I can change the W into 7 like we just found. That's this 7 right here. It's a W7, so I'm going to put it in for that W. Therefore, length is 2 plus 3 times 7, 21. Length is 23. So the answer to this problem is it has a length of 23 and a width of 7. 23 plus 7 is 30. So one length and one width is 30, therefore the other length and the other width is 30. Gives us a total of 60, which is what we said the perimeter was. Thanks for watching. Have a great day.